Hello guys, in the Blynk 2.0 series of video, I will tell you how to control the multiple servo motors through the new Blynk 2.0 IoT Mobile App and Web Dashboard. We will control the 5 servo motor to demonstrate to you. This is Bhupendra Singh and you are watching our YouTube channel SME Dehradun. We need the following components for the project: NodeMCU ESP8266 Wi-Fi board, SG90 servo motor 5 in quantity, a few connecting wires, and you can use breadboard or zero size PCB to connect the components. And this is the circuit diagram. You need to connect all the servo motors with the NodeMCU as per this circuit diagram. Let's introduce the hardware to you. These are the 5 SG90 servo motors that I have. This SG90 servo motor has 3 pins. The first wire, that is brown in color, is ground. Middle one wire, that is in red color, is VCC, means 5 volt, and the last one wire, that is in orange color, is data. Alright, let's open the packaging of all servos. I have soldered the headers in the zero size PCB so that I can connect the servo motors properly with NodeMCU. Let's connect the servo to the zero size PCB. I have connected all the servo motors directly to the PCB, and it's better because it's very tough to arrange the servo in breadboard. Now connect the VCC pin of the servo motors to 5 volt, ground to ground, and data pins to the D2, D3, D5, D6, D7 number pins of the NodeMCU. Take the reference from the circuit diagram. So all the connection has been done. Now we will create the project template on the Blynk website. So open the blynk.cloud website in your web browser. Link is also available in the video description. Once you have opened the website, you can see the option to login. If you are a new user, then you can create your account by clicking on create new account. As I already had an account, so I am logging into my account. Once login, you will get the Blynk website like this. You can see the new template button to create your new project. If this is not your first project, then you go to the template tab, and here you got the new template button. Now click on the new template to create your project. Write the name as multi-servo control with new Blynk tool. Select the board as ESP8266. Select the connection type as Wi-Fi. Write the project description as multiple servo control using NodeMCU ESP8266 and click on done. We have created our project template. Now click on the save to save your project template. Now I will add this project template to the new device. Click on the search tab. Here you will get a new device button to add the project to a device. So click on the new device button, and here you will have the 3 options. So click on the from template. Here choose your project template and click on create button. As you can see, we have got our project credentials. You can also see your project credential in the device info tab. Now we will add virtual pins to our project template. So click here and click on the edit dashboard. Here click on the data stream tab. Click on the new data stream button and click on the virtual pin to create virtual pin for servo motor. In the property, write the name as servo1, virtual pin as V0, data type is integer, search the unit type as degree, write the maximum value to 180 as SG90 servo motor can rotate maximum to 180 degree. And guys, must read the datasheet of the servo motor that you want to connect, because you need to change the maximum value here as per your servo motor. Once you write the maximum degree of the rotation here, then click on the create button. Similarly, we create the virtual pins V1, V2, V3 and V4 for other servo motors. Now we create the virtual pins for output of the servo motor so that we can display the output of the servo motor. So click on the new data stream and then virtual pins. Write here the name as servo output 1, pin as V5, data type as integer, units as degree and max value to 180. Now click on the create button. Similarly, we create the virtual pins V6, V7, V8, V9 for the servo output. So we have created all the virtual pins for the servo motors. Let's configure the web dashboard. Click on the web dashboard tab. We will drag and drop the gauge and slider in the dashboard. We will drag and drop the 5 gauge widgets in the dashboard. We also add 5 slider widgets to the dashboard so that we can operate the servo motor using the slider. Now hover the mouse to the first gauge widget. Here click on the setting icon. In the gauge setting, choose the data stream as servo output 1 V5. You can also change the color of the widget and click on save button. Now open the setting of the second gauge widget. Choose the data stream as servo output 2 V6 and click on save button. Open the setting of third gauge widget. Choose the data stream as servo output 3 V7 and click on save button. Open the setting of fourth gauge widget. Choose the data stream as servo output 4 V8 and click on save button. Open the setting of fifth gauge widget. Choose the data stream as servo output 4 V9 and click on save button. Now we will configure the slider widgets. Open the slider setting of the first widget. Choose the data stream as servo 1 V0. Change the color as yellow and click on save. Similarly, we configure the remaining slider widget for the servo motors. Click on the second slider. Choose the data stream as servo 2 V1 and click on save. Click on the third slider. Choose the data stream as servo 3 V2 and click on save. Click on the fourth slider. Choose the data stream as servo 4 V3 and click on save. Now click on the fifth slider. Choose the data stream as servo 5 V4 and click on save. We have configured a web dashboard for our project. So finally click on the save and apply button to save the setting of our project. You can see your dashboard preview. Now time to configure the Blynk IoT Mobile App. Go to the Android store or App Store and search for Blynk. You will get the Blynk IoT app. Download and install the Blynk IoT app. After the login to your app, you can see your project template like this. Click on the template to configure it. Here, click on the setting icon and inside, click on the plus sign to add the widgets to the dashboard. Scroll below and click on the gauge widget to add in the dashboard. Add 4 more gauge widgets to the dashboard. Arrange the gauge widgets in the dashboard. Now add 5 slider widgets to the dashboard so that we can control the servo through the slider. Right? Arrange the widgets in the dashboard so that we can easily control and we can see the output in the app. Now click on the first gauge widget. In the setting icon, select the title alignment center. Select the data stream as servo output 1 V5 and back to the dashboard. Click on the second gauge. Select the title alignment center. Select the data stream as servo output 2 V6 and back to the dashboard. Click on the third gauge. Select the title alignment center. Select the data stream as servo output 3 V7 and back to the dashboard. Click on the fourth gauge. Select the title alignment as center. Select the data stream as servo output 4 V8 and back to the dashboard. Now click on the last gauge widget. Select the title alignment center. select the data stream as servo output 5 V9 and back to the dashboard. All the gauge widgets have been configured. Now click on the first slider widget to configure. In the slider setting, select the title alignment to center, select the data stream as servo 1 V0 and turn off the send value on the release only button. This option must be off so that while we move the slider, the value of the slider simultaneously sent to our NodeMCU board and can operate the servo motor to that degree of angles. Okay, now back to the dashboard. Click on the second slider, select the title alignment to center, select the data stream as servo 2 V1, turn off this option and back to the dashboard. Click on the third slider, select the title alignment to center, select the data stream as servo 3 V2 and turn off this option and back to the dashboard. Click on the fourth slider, select the title alignment to center, select the data stream as servo 4 V3 and turn off this option and back to the dashboard. Click on the fifth slider, select the title alignment to center, select the data stream as servo 5 V4, turn off this option and back to the dashboard. So we have configured the Blynk IoT Mobile. Now it's time to work on programming code. So go to the video description and click on the link to download the programming code. This link will redirect you to my GitHub repository. Here click on the code button and then download. After downloading the code, go to the download location. You will get this programming code zip file. You can download the unzipped software from the video description if you don't have one. Okay, so right click on it and click on extract here. You will get the extracted file. So go inside this folder and this is your program. Open it with the Arduino IDE. This is the program. At the top of this code, these are the Blynk credentials. We need to replace them with your Blynk project credentials. So go to the Blynk website, click on the search tab, you will get your project here. Click on the device and inside click on the device info tab. These are your project credentials. Copy these credentials and replace them. Below we have defined the Blynk serial and a few ESP8266 header files. Below we include the servo.h header files and define the servo 1, servo 2, servo 3, servo 4, servo 5 as the variables for the servo motors. Servo library must be installed into your Arduino IDE. This is the default library of the Arduino IDE. But if this library gives you the error for the library, then you need to install it. So to install the servo library, go to the sketch tab. In the include library, click on the manage libraries. The internet must be connected to your computer this time. Search here for servo.h. As you can see, this is the servo library. You will get the install button here. Click on it to install. I have already installed the servo library. After installation, click on the close button. You also need to install the Blynk library. So a link is available in the video description to guide you how you can install it. Okay. Below we define the auth character type array and call the Blynk authentication token. Here you have to write your Wi-Fi name and password of your Blynk Wi-Fi or hotspot in which you want to connect your NodeMCU board. Below we have called the Blynk write V0 function in which when we slide the slider of V1 virtual pin, we store the values of the slider in the S0 integer type variable using param as int function. At the same time, we write that value to the servo1 motor using servo1.write command and display the angles of the servo motor to the gauge widget of the V5 virtual pin. Okay. Similarly, we call the function for the second servo motor. We call the Blynk write V1 virtual function we store the slider value of V1 virtual pins to S1 and write that to the Servo 2, and at the same time we update that to the gauge widget using the V6 virtual pin. For the third servo, we call the Blynk write V2 virtual pin. We store the slider value of the V2 virtual pin to S2 and write that to the Servo 3. And at the same time, we update that to the gauge widget using V7 virtual pin. For the fourth servo, we call the Blynk write V3 virtual pin. We store the slider value of V3 virtual pin to S3 and write that value to the Servo 4, and at the same time we update that to the gauge widget using V8 virtual pin. For the fifth servo, we call the Blynk write V4 virtual pin. We store the slider value of V4 virtual pin to S4 and write that value to the Servo 5. At the same time, we update that to the gauge widget using V8 virtual pin. If you want to control more servo, then you can define it in the similar manner by the blynk.write function. Now in the setup function, we begin the serial monitor at 9600 baud rate. We define the servo motor data pins to D2, D3, D5, D6, D7 using servo.attach command. Right? Below we begin the Blynk server authentication by passing the authentication token, SSID and password arguments. And in the loop function, we call the blynk.run function. So this is the complete program to control the multiple servo motor. Now connect your NodeMCU board to the computer and go to the Tools tab. In the board option, select the NodeMCU 1.0 ESP12E module. If you don't find the board here, then you need to add the NodeMCU board to the Arduino IDE. Link is available in the video description to guide you how you can install the NodeMCU or ESP32 board to the Arduino IDE. Again, go to the Tools tab. In the port option, you will get the COM port number as I got COM5. If you don't find the COM port, then the link is also available in the video description to show you how you can install and find the COM port for your board. After the selection of the port, click on the upload button to upload the program into your NodeMCU board. As you can see, the program has been uploaded to the board. Now, time for the live demonstration. Power on the NodeMCU board. I have a mobile charger that I am going to use as a power supply. It will take hardly 5 to 10 seconds to come online. Let's open the dashboard of the Blynk IoT app. While I am sliding the first slider, you can see the first servo is rotating with the same time without any delay. Sometimes it will take time due to the internet speed of your Wi-Fi. You can see the live demo to control all the motors. I have also logged into another mobile with the same username and password. You can see while I am sliding the slider, at the same time it shows the slider moving in the other mobile, and the servo is also rotating. You can log in to a maximum of 5 devices at a time with the same login credentials and control the same application. You can also control the servo with the web dashboard from the Blynk Cloud website. So go to the Blynk website. In the search tab, you can see your project. The project is online because our NodeMCU is online. Click on your device and you can see your dashboard. While I am sliding the slider, you can see the value in the gauge is changing as per the slider. So guys, this is how you can control the multiple servo motors through new Blynk2.0 IoT Mobile App and Web Dashboard. You can use these servo motors to control any robotic jaw, any customized hand, or to control any angles or flow of the water in the tap as per your requirement. So thanks for watching. Please like and subscribe to our channel and videos, and stay with us for more innovation.